Why do structures buckle and snap through? Imagine a tall, slender tower or a curved shell suddenly changing shape without warning. It might seem like magic, but it's all about how structures respond to forces. When a structure is pushed or squeezed, it can suddenly bend or shift in ways that cause failure. This is what we call buckling and snap-through. Buckling happens when a component like a column or a beam under compression suddenly deforms sideways or changes shape. Even if the stress on the material isn't high enough to break it, the shape change weakens the structure and can lead to collapse. The main reason this occurs is because of instability caused by compressive forces. When a long, thin piece is squeezed, it wants to shorten. But if it's slender or shaped in a way that makes it easy to bend, it might suddenly bow or bend sideways instead of just compressing straight down. This sudden shift is buckling. The load at which this happens is called the critical buckling load. It's like pushing a stick until it snaps sideways. Imperfections in the structure also play a big role. No structure is perfectly straight or perfectly aligned. Small flaws in shape, material, or how the load is applied can cause uneven stress. These tiny imperfections grow under pressure and make buckling happen sooner than expected. Think of a slightly bent straw that snaps when squeezed just a little too hard. The shape and how the structure is supported matter too. Longer, thinner, and less supported members are more likely to buckle. For example, a tall, narrow column with little lateral support is more prone to buckling than a short, thick one. Different types of buckling include column buckling, where long columns bend sideways, local buckling, which affects small parts like flanges or webs in beams, and snap-through buckling, where a curved structure jumps from one shape to another suddenly. Material behavior is also important. Buckling usually happens before the material actually breaks or yields. After buckling, the structure might fold or form creases, but it can still carry some load. Sometimes buckling leads to cracks or other failure mechanisms like stress corrosion cracking. Snap-through is a special kind of buckling where the structure jumps from one stable shape to another, like a bent beam suddenly snapping to the opposite curve. This is common in shells, arches, or curved panels. It can cause sudden failure or loss of function, often catching engineers off guard because it happens so quickly. Understanding why structures buckle and snap through helps engineers design safer, more reliable products. They choose materials with enough stiffness, shape components to resist lateral bending, add supports or braces, and consider imperfections and real-world loads. Buckling is a sneaky failure mode because it can happen unexpectedly and at loads lower than those needed to break the material. Recognizing these failure mechanisms is key to preventing accidents and ensuring structures stay safe over time.